Okay, hey everybody. This will be the second CAD tutorial. We're going to be doing the part you see here, which is the spindle. It's like the hub on your car. It's what the wheel attaches to on these three bolt holes there. And then the five sort of half circles you see, or six, sorry, going around are where the brake disc will mount. Then these two little ridges here, you can see this little band and this little band are where the wheel bearings are pressed onto. So that's what the wheel actually rotates on. Before we get started, one quick tip I think people are having trouble with. If you're loading an assembly or the whole car and there's multiple parts, make sure you go File, Preferences, Assembly Load Options, and As Saved. That will probably fix most of your problems. As well, if you're opening a part, make sure you open it NX and open the part from NX with this open menu. Don't try and double click on the part from like the file browser, because it's going to try and route to like a different program. It tends not to work, especially on the school computers. Okay, so for this tutorial, I've already taken down most of the dimensions. I'm going to try and move a little bit faster, otherwise this is going to take too long. So you'll see the process and then you can do it at your own pace. So we're going to revolve the main shape of the hub, the spindle first. So we'll make a sketch on the YZ plane. Okay. And we're just going to give the main features, and then we'll go back and give it all dimensions. So I'm just roughly drawing all the approximate shapes that we'll have. So remember that I zoom with the scroll wheel, and I rotate by depressing the scroll wheel, and so I can move one way, or move the part around by scrolling in or out in a different area. So we'll trim off the little excess here, and then we'll start dimensioning. Dividing everything by 2 because when I measured, I took diameters everywhere. As you can see, I drew very roughly the shape, but as we give it dimensions, you'll see it come together. And like before, I'll post the finished part with the tutorial so you guys can measure all this for yourself. Or you can follow along as I type it in. Whatever floats your boat. Okay, so now we'll give the axial dimensions. We'll go from one reference point, which is going to be the y-axis. dimensions are a bit all over the place, but they're there. Finish that sketch, then we're going to use a revolve. So we're going to select our curve, specify a vector which we're revolving around, here the y-axis, specify a point, so we'll go down to this little corner, and yep. So that's the basic shape of our hub. So now we will go to making the cutout for the brake disc mount and then the relief next to the brake disc mount. We'll follow that by the cutout for the mounting point of the wheel. So make a sketch on that revolve. Okay. First thing we're going to do is to reference lines, referencing the edge of that revolve, where the brake, so this is for the brake disc, so we're referencing where the brake disc sits. Remember that I use F8 to orient to the nearest sketch. Sorry if I forgot that. Or sorry, not the nearest sketch, the nearest sort of plane, angle, whatever. Nearest view, I guess. Okay, and then same thing to the bottom edge there. Okay, so that didn't actually make a full constraint, so what we can do is measure to that surface. And that's a constraint because it's going to measure that surface for reference. Okay, now we will make a reference line for where the brake disc mounting point will sit. We'll make an angular dimension as it's 30 degrees offset. Trying to measure the inner angle. I prefer that we measure it's trying to measure the outer angle. There we go. 30 degrees. Perfect. It knew what I wanted already. Okay, so now we'll make the mounting point for the brake. Make that cut out as a diameter of 0.5 inches. And we're going to make that sit on the reference point. There we go. So we made a point on curve constraint between the center of this circle to the arc that we made here. Okay, and then make that a reference so that we can use it later on for this or for that location. Then now we'll make the, actually while we're at it, this should be a reference as well. Okay, then we'll make the relief next to the brake disc. So that was just a curve with a radius, and the same thing on the other side. Okay, so I try and avoid it making automatic constraints because that usually messes you up later. So give each of these curves a 1-inch radius. So that's kind of a weird, sharp, triangular shape sort of, but what we're going to do later on is make a fillet at that little corner at the base there. Okay, and then for dimensions, give some linear dimension. We'll space these apart at 1.5 inches. I think maybe I meant 1. Maybe that's supposed to be 1 inch. Okay. Actually, I don't want to reference that line. It's not really in the same sketch. I prefer to reference the vertical axis because that will always stay constant. Okay, and that that's going to be P23 divided by 2. So this big dimension f of 2. And yeah, that 1.5 is too large. Make it 1 inch. Perfect. Okay, and then last thing we'll do is trim that, and well, that's a reference, that's fine. And then we'll draw an arc from here to there, and then make it match the reference there. Because we can't use the reference arc for the actual extrude, we need to draw an arc that matches it. Okay, so now we have a little cutout and we have a relief next to it. Excellent. Then we'll make the sketch for the the wheel mounting point. The wheel stud actually is inserted there, and then we put a bolt onto it. It's kind of hard to see without the car. But, and you'll notice that I like to make all the sketches, if you can at least, in one place and then extrude them out afterwards. It simplifies, in the end, your part, and it makes it easier to make changes at a later date. Because then you just need to change those sketches, you don't need to mess with weird references between different parts of the different surfaces on the part. It's all in one place. So for that sketch, we'll make the hole for the mounting. We'll make the hole there, which is the diameter of something that I did not measure. I think the number of times I've done this by now, I remember to measure stuff. 0.41 inches. Okay. That distance did measure 1.9. Okay. Now we're going to do something a little tricky here. We're going to make the relief. So we will make a sketch like we did before. And so we'll make two reference curves. This one we will measure the diameter to this. That should be 3.08, not 3.02. Okay, well, we'll do it like this, and then because we have all the sketches referenced nicely, I can change that dimension later, and everything will update. So I can show you that. Okay, and then now for this cutout, it's going to be kind of a weird shape, but I'm going to make an arc that's tangent to that arc. So this arc is this same center line, same like center, and then touches the outside arc. And then we'll make an arc that's tangent and hits that next arc. And then we'll give a linear dimension between here and the center point of 0.75 inches. Okay, then we need a reference line across which we're going to mirror something. So that's reference. We'll give an angular dimension. Here, so see here, try to make an automatic perpendicular constraint. So I'm just right-clicking and delete that perpendicular constraint. So often NX will do this. It's both helpful and annoying because sometimes it's helps you make your part, quickly, but at the same time it's annoying because it'll snap to a position that, and then you try and change it and it won't let you change it because it's already constrained. So if something says over constrained, look for like extra constraints that you didn't make yourself that sort of just popped up. Okay, so the reason we're doing this is because if we extrude like just that little triangular shape like this, it's actually just going to cut that triangle out of this far, like the last part of the revolve there. And what we actually want to do is cut out this circle and then cut out a big window next to it that is the relief, which it'll make sense in a second. So we're going to mirror the curve. First we have to trim that. First we'll have to mirror that. First we'll have to trim the extra. Okay, that should be fine, I think. I'm going to mirror a curve. So select that curve. Since they are continuous and tangent at this point, it selects both of them. Select a center line, and it'll mirror it over to the other side. Okay, and it should have made the same like point constraints as before on the mirrored side. So then we should be able to trim to there, and trim, leaving just that in the center. Okay, and alright, so it looks like it lost some of the constraints when I did that, so what I'll do is measure a distance. Can measure, or probably actually just remake that constraint. No, bad idea. Okay. Okay. I don't know why it's... Alright, we can just give it that dimension. And this dimension, we want from that endpoint to the z-axis, which is 0.75. Okay, right. Okay, I'm not sure why this is not working. That we don't need. I don't know why it needs that dimension. Okay, anyways, this will work fine. I'm not sure if it'll update properly, but whatever. Alright, so let's first change the issue with the sketch, which means, of course, since... Okay. Since my sketch line is so out of place, I don't know what's referencing what. We'll get there. Okay. So, I think this is the one that's incorrect. Yep, that should be 3.08. finish sketch. So now the revolve should update, and our sketch here should also update. You can see that that's now 3.08. Perfect. Okay, so now let's extrude some stuff. Go to extrude. We'll start with the break disc. So now we're going to extrude from until extended. So extended up from this face is the start point. The end point is extruded out from this face. So go from there to there. The reason we did that is so it'll cut through a fillet that we're going to put on the edge here later. Anyways, you want to make sure it goes through the whole thing. If it goes through just those two surfaces, if you put a fillet later, it's not going to cut that too. You'll have like a weird thing going on. And then we can sketch, select sketch 4, and extrude that one. Again, till extended from here, till extended to the other side. That should work fine. Subtract from that body. Okay. And if we pattern that around, we should get the part we want. So we will first put a little edge blend right here of 0.25. Okay, perfect. And then we will pattern parts. Okay, so we'll pattern that edge blend and pattern this hole. Pattern, circular, specify a vector, that one, specify a point. Just select the edge, which will select the center point. It's fine. So we want 6 of those. Okay. That should work fine. Perfect. Okay. Then we'll select extrude 6. Pattern that feature. Circular, specify vector. We only want 3 of those. Specify a point. Select the edge. Okay. Wow, look at that. Perfect. Alright. So, that's most of it. Now we got to do this inside, hollow it out. I'm just going to hide some of the sketches so I can see what I'm doing. Okay. Now, just really quickly, I want to explain a difference in how you can do CAD here. So, for this part on the edge here, on the end, I had the full circle and then I cut away the relief. That's CADing as if you were going to follow the machining procedure. It is nice and it makes sense because you see how the part will be made, but like you saw how I do that little cutout, it was kind of awkward as opposed to just making a nice little triangular shape that fits on there, and we just add to this central revolve. So for the inside, I'm going to do it the opposite way because it makes it a lot easier. I will first cut out a straight circle that is like the whole inside, and then add back in this little extra whatever radius that adds material around these bolt holes. So what I'll do first is a sketch, same place, just of the right diameter. I don't know. I tried to make self-tangent to something. I don't know what. That diameter is 2.302. Okay. Finish. Extrude. Value from 0 until next, which is going to bring it all the way to the end. Subtract from here. Yeah. Should work. That worked. Okay. And then we'll simply add back on the little piece here. Okay, so make sketch, make a little circle. That's going to be the bolt hole, and then around it is, so here the bolt hole is reference. Actually, I don't even really need that. Just give a dimension. Here is 1.2. This diameter is 0.553. Okay, and then what we'll do is make another line. We want that at 0, okay. Make another line and then trim off the excess. So that's what we'll be adding in. So we'll finish that sketch. Extrude that sketch at a distance of 1.32 inches. We'll be uniting with that body. Oh, I think it's trying to extrude out. Other way. There we go. Now we've added that in, and then the last thing we'll do is sketch on this plane. Right there. So it already centered itself around the hole we just made. And whatever that is, 0.213. So what it did is it like saw this sketch and it automatically snapped to the center of that line. So that's fine. That's one of those like it snaps to automatically and it works nicely and it's great. And then we will make a little hole here. And here we're subtracting from that body. And we gotta flip it around again because why not? Alright, so there's a little hole there. So hide that. Hide that. And we'll select extrude this one. And extrude that one. And we'll pattern that around. Circular on the y-axis. Specify point, center, 3 of those. Perfect. Okay, so that's the part pretty much done. And now we can add in, actually, you know, there's one little hole there that I forgot. This guy. Measure that real quick. Measure the diameter. 0.625. And the depth of that hole. Here to there. 0.2. Okay, so we can do a little sketch here. Okay. And okay, 0.625. So even though the sketch is way back here, we'll extrude that with a starting point here, and then a value of 0.625 going the other way. Subtract from that body. Okay, until extended. Start there. Oh, it's 0.625 measuring from there. So we'll do a formula where we measure a distance from there to there. Okay, so that will position position us at the right place, plus 0.625. No, not 0.625, 0.2, sorry. That's not right. There we go. Okay, this is one of those times that maybe would have made more sense to put the sketch directly on that surface, but whatever. Hide, and then we'll pattern that feature. So, no, 3. Sorry. Yeah. Okay, so then the only real thing left to do is put in some of the nice edge blends that make this look proper. So 125.125, okay. And then this edge blend, so we see how it does this weird thing here? That's because we put the edge blend after making this cut. So that's extrude 5. So if what we do is bring the edge blend before extrude 5, which it should let me do, then it makes more sense, because we would make the edge blend before we cut that out, and then we'd cut through that blend. So now you have a nice little part. Edge blend, edge here, edge there, make it much bigger. Okay. Actually, if you hit Shift and select an edge, it'll remove it from the list. This one, if we bring it before, yeah, no. Okay, it doesn't like that. Why doesn't it like that? Okay, well, whatever. Okay, maybe we should have done those edge blends first, but it's not the end of the world. Sometimes you realize something didn't work very well, and you have to go back and redo it, or change the order of sketches. But that's not going to be particularly useful for the purpose of this tutorial, to go back and mess with it a bunch. So, just going to put in a couple. Okay, and there will be some little radiuses here as well. It's a little bit arbitrary. This one will have a radius. You can select an edge blend and keep adding edges to it. Okay. And That's what we'll do, so we'll go in here. That's a bit too big. The error there was like it was trying to blend above the edge of the part, which you can't really do. So there we go. Nice little blend there. So there you go. That's pretty much the part done. And so yeah, so like always, if you have any trouble with this, just come let me know. This part's, you know, fairly complex. It's one of the more feature-heavy parts, I guess, on the car, so it'll be a good exercise for people. Like you can see, like there's a couple little mistakes here where really we should make the blend before we do the extrudes and stuff, because it gets weird little stuff, but I'm not going to go back and change everything right now. Yeah, so then next time what we'll try and do is an assembly tutorial where we mate the brake disc to the spindle that we made. So yeah, thanks for listening.